Hello, ladies and gentlemen. Welcome to my shift. My name is Dima Maleev, and I will be your next host for next couple of hours. So you are on junior track, and we are happy to have you here. Uh, just a couple of words of Geekle. We are now doing some of the biggest Node.js online seminar in the world, and we are happy that you are here. We at Geekly, we want to deliver world-class speeches from world-class speakers to any part of the world, and we are super thankful for that for our generous sponsor, the Salesforce and Heroku. We are starting the next shift with our next speaker. His name is Yuri. He lived in Ukraine, he lived in China, he lived in, now he's living in Switzerland. He's working as solution architect at EPAM, and he's doing amazing YouTube channel. So when you'll have a free time, just check it out. That's really amazing. And today, Yura will speak about multiplayer game dev in web. Yura, your turn.
Oh, hi guys. I'm super glad to be alive, and yeah, it's amazing to see this kind of scale of conference happening online. It's truly cool. So thank you very much for having me here. Right. So what I want to do is today I will be talking about game development. Right. So game development. This is an interesting subject, right? So if you think about it. It is one of the most challenging domains, right? Unlike other domains, game development combines artificial intelligence, game mechanics, physics, all sort of optimization, sophisticated networking. So there is really a huge space for honing your engineering skills in that area. So my first paid job was in game development, wasn't JavaScript, but when JavaScript was finally in a shape to give you an ability to write production-level games, I was so excited. I actually wrote one of the first books on JavaScript game dev, and since that time, I'm pretty excited about what you can do in JavaScript. So today we will talk about multiplayer game dev. So let me know if you see my screen. Can you please bring my screen on? Right. So, oh yeah, thank you very much. That's much better. That will be much more informative than my face for the rest of this talk, right? So we'll talk about the JavaScript game development, and this session will be slightly special because I will be doing all the coding live with you. I want to show you guys that making a game in JavaScript that is fun and sufficiently interesting is actually not that hard, right? So I'll be doing all the coding live, and moreover, I will try to do the deployment live. So I have set up a small server that you can find the link to from my little website. So if you are curious, once I'm pushing my commits from here, you will be able to see that over the internet and try it out. I'm not sure if it will explode or not, but let's give it a shot. It may be fun, right? So our plan today is to create a Node.js JavaScript game using only web stack. So we'll be using JavaScript and Canvas and SocketIO for the communication. And we'll talk a little bit, if you haven't had a chance to work with these technologies, we'll talk a little bit about each of them. And I'm pretty sure you will be excited to learn more if you haven't yet after this session. So let's kick off. So our idea is we'll build the multiplayer version of 5 in a row, but not for 2 players. For as many players as you want, and all in real time. So no waiting for the turns. Everyone is making the turns at the same time. So let's start off, right? So I'll put down my presentation, and we'll look at what we have here, right? So since we have a very limited time, I took a little bit of freedom to build a basic application. I mean, who would want to look at me typing basic HTML, right? We all can do that. So I have created a very basic app here. That is just a plain HTML, no framework, no Angular, React, no game dev libraries or frameworks, nothing. It's pure HTML JavaScript. All it does, it has a little box with the welcome. You can say hi here. And for now, at this moment, it will just print it back here. No server involved. It's just immediate printing from the client to the client, right? And I also have created a simple server. By the way, guys, if there are any issues with seeing the code that I'm showing on the screen, please let the moderator know, and I'll increase the font sizes, right? And also, I have created a very simple server here, right? So this is a typical Node.js Express server that does nothing but serving static files. So we're starting from nowhere. It's just a blank path, right? So now, the first thing to do with the multiplayer game is obviously to build some communication between your client and the server. And with SocketIO, it is super easy. So what is SocketIO? If you haven't heard, it's a library to enable real-time communication in web. And I have already installed it on my server in Node modules. You can do it without SocketIO. You can do that by hand. But SocketIO gives you slightly higher level of abstraction, like game rooms, like reconnecting, like buffering the messages, etc., and so on. So it is much easier to start off with something like SocketIO. So let's go with SocketIO. And so my goal is to see that this guy over here is talking to the server. So I'll take SocketIO, and this is my Express server. What I'll do is I'll just wrap my server with SocketIO. And SocketIO indeed acts like a wrapper. It will intercept everything that belongs to SocketIO, and everything that doesn't belong to SocketIO will go to the server. So if you have your APIs, you can still have them with SocketIO. And then the communication is super simple because it's just normal work with the events. So we'll say that whenever someone is connected, we'll do something with that client. And to do something with that client, SocketIO is giving us an object that is called sock. Nothing to do with the socks that you're wearing on your feet. It's short for socket. And what we can do is we can just say sock emit to send the message to that client. So I'll send the message. Message is not special. It's just the kind of thing that you're sending. I could call it text or a chat, whatever. And I will say hi. Now, this is my server side. And by the way, on the background, I have NodeMon running. And it will restart the server if I'm making changes. So you should see that in the place. By the way, this is not hi from the server, it's hi from me. So on the client side, connecting SocketIO will be also like super simple. So all we have to do is to add the script, source, SocketIO, SocketIO.js. So as I said, SocketIO acts like an interceptor. So it will intercept the call to the script and feed it to the client. Although I don't have this file physically on my hard drive, it will still be there. So on the client side, as I said, I wrote a little bit of code, right, just to not write the boilerplate, right? So I have the log function that prints the values here in the screen. I have onChat submitted that just takes the value from the field, and well, right now it just sends it back to the same screen. And I have one more function that I'll be using later, getClick coordinates, also pure DOM JavaScript function to find out what are the relative coordinates of the click on the element. They all are quite easy, right? So what we'll do here is we'll say sock equals IO, just the same way from the client side. And sock on message. So whenever we receive a message of type message from the server, what we'll do, we'll just log it. So I'm passing the function as the listener to log the value. Let's see. Wrong one. So, and now this hi now is coming from the server. So this message has been just sent from the server to my client with the real-time communication channel, right? So step one done. We have established the real-time connection between the client and the server. So what next? Let's go a little bit further. Let's establish the real-time communication between two clients. I have the second client here. And I'll try to put them side by side so that you can see both. Again, it is quite basic, but in just 5 minutes, you can build a very functional chat. So, right. So what we want to do now is instead of just sending hi from the server, whenever somebody submits the chat message, we'll say sock.emit, and we'll say that I'm sending message to my server with the value of text that the user has entered. Right. So my event listener currently doesn't have the access to this sock object, so I'll very quickly wrap it in the other function. And this way, I'll pass it down to the event listener. So just make sure that everything here works correctly, right? So now the client will be also sending messages to the server. And on the server side, if we have a message, the next step to do is write a listener. So instead of just sending hi, I'll say sock on message. So when the message is coming from that client, what I want to do, I want to say io.emit and send it this way to everyone who is connected to the server right now. Oh, sorry. I need obviously to pass a function here that accepts the text that I will receive, and I'll just send that text to everyone. So when we're doing sock emit, that means send to one client. We're doing IO emit, that means send to everyone who is currently connected to the server. So with this, let's try to refresh both windows and write tests. And now we have clients talking to each other, right? So that's a brilliant beginning for the new amazing game, right? And initially, I wanted to make a game of rock, paper, scissors, but that was with just buttons, no graphics at all. So I thought it will not be fun. So I decided to go and work with graphics a little bit, right? So we'll have to go fast because there is plenty of code to write. But on the top here, there is a big white space. What do you think is it? It is because we have a canvas right here that we can draw on. So if you haven't worked with graphical APIs, Canvas is actually quite simple, right? So working with Canvas is a matter of getting Canvas. So query selector, let's get our Canvas. And then in order to draw something on it, I need to get the access to the graphical APIs. Now, Canvas supports multiple graphical APIs. It supports both 2D that I will get right now, get context 2D. And it also supports things like WebGL. And I mean, we will be drawing rectangles and lines for now to start off with. But Canvas is extremely powerful. Back in 2013, I believe, Mozilla joined up with Unreal Engine. They ported Unreal Engine 3, I believe, at that time, and they were running it on WebGL, in Canvas, in browser, and it was running smoothly, right? So you can write a complete game engine with the use of Canvas, so don't let this simplistic API fool you. It is indeed a really powerful thing. So, and then once you have context, you can start execute commands, what to draw on the canvas. So I'll say fill rect, oops, rect, and I need to pass the coordinates. Now, with Canvas, the coordinates are working like this. You have top left is 0, 0, X is going to the right, Y is going down, right? So you can imagine how the rectangles will be. So I'll say 10, 10, 50, 50 will be the place where I want my rectangle to be rendered, right? So now I have the first hello world with the graphics, right? I can draw a rectangle, which is amazing. By the way, if black you don't like black too much, you can always change the color with fill style, and fill style just accepts the normal CSS color. So if you want it to be coral or some other exotic color, you can do that. It will work great. Now, before we move on and before we continue, right, we'll be working a lot with the canvas in this session. You see, all the methods that you're calling to draw something on canvas, they are executed against the context. So if you want, you can build the functions, and each function will receive context, context, context. It will be just like too much. It will not be very convenient. So what I will do right now, I'll refactor this code a little bit, and I'll wrap this context in a closure so that I don't have to care about it anymore. So I'll create this closure, this function that's called create board. And board will be my abstraction for everything that is related to the game rendering. The rest of my application, if I would be working with something like Babel or Webpack, and I would definitely put it as a separate module. I don't want to do that right now. I'll put everything into a single file, but you'll see there is a clear separation between the logic of the game itself and the logic of the rendering of its components. So create board, it will accept canvas, canvas, and I'll just copy paste this code here. And I'll create a function called fill rect, just to start off with. We'll accept X, Y, and color. And take this code, put it to this function. Fill style will be the color. And then I'll put XY instead of 10, 10, so that I can have some freedom where to draw my rectangles. So 20, 20, something like this. Now I can return from the outer function, I can return the inner function, and that inner function will always have now the access to the context and to canvas. And that will be like this, fill rect. Again, this is not a typical, not something that is have to do with the game development. It's just a way to organize your code a little bit better, right? So now I can do fill rect and take it from payboard and passing the canvas. And now I don't need to care about context anymore. The context is somewhere there inside of create board. All I can do just fill rect 50-50. If I do not pass the color, it will be black by default, so it will not break. So let me just quickly check it. Right now, it works. Perfect. So now this point seems like a good attempt, good opportunity to try and upload it, right? So I'll just do quickly. CMP is my alias for commit and push. So I'm pushing right now. My continuous integration service will hopefully pick it up, build this, and deploy to game.yuri.com. So just give it a try. It should be there in a couple of minutes, or it will explode. We'll see in a couple of minutes. Right. So we have now the way to render something, and we have the way to talk. Right. So now let's combine the two. Right. Let's add the interaction, and we'll have the very basic tool to start building the game. Because if you think about it, essentially all the games are boiling down to render things, get user input, update the world, and render things again, and so on. This is something that is called game loop. So let's finish our game loop with handling the user input, right? So we'll need some sort of a function to handle clicks on our canvas. Let's do that. And it's usually accepting the event. So I'll add an event listener. Canvas, add event listener. And when there is a click event, I will call onClick. So what I want to do in onClick, and here's where my first helper function is coming. I just don't want to write this code on screen, but it is trivial. I will get the relative coordinates of the click inside of that canvas, in canvas coordinate system, not in the browser or window coordinate system. So what I'll do here is we'll get XY, and that will be coming from get click coordinates, and element is canvas. And the event is E, right? And now, in order to see that I have achieved something, that click does something, I'll just fill rectangle. Here we're coming to an interactive application, right? See, I can click and create rectangles at the same time. How cool is that? All right, but let's go. Wait for it. It's going to be better. So one thing, I just want to click in the middle of rectangle. So I'll just shift where rectangle is rendered. So it's not awkwardly in the corner, but when I'm clicking, it's right in the middle where it's rendered. All right, perfect. So now we have clicks, we have rendering, we have communication. Let's start making turns. So let's say that when we click on the board, this is the turn that we're sending from one client to the other client, right? So what shall we do? And it's super simple. It's exactly the same like chat. You see, the pattern is exactly the same. You, instead of sending the message, you want to send the details of the turn to the server. So instead of filling rectangle, I'll take it out. I'll say that I want to emit a new kind of message that is called a turn. And that turn will have X and Y. I'm just sending the coordinates. Everything else, I don't care. Perfect. And now I've sent the turn to the server. Now server needs to react on it. Well, it's like one line of code, because reaction is exactly the same as on message. So we'll say that whenever server is receiving the turn, it will not analyze the turn right now. We'll get to that, right? But right now, it will just take X and Y values and to IO emit, and IO will send it to everyone, including the client that sent the message. and I'll just broadcast this turn to everyone who's connected. And that's going to be X and Y. All right, so now I'm sending the turn to the server. Server receives it, sends it back. Now all the clients need to do something when they receive the turn. All right, let's go back to the client side and add one more event listener. We'll say on the client side, when I'm receiving the turn from the server, so somebody, maybe me, maybe that's my turn, when somebody made a turn, I'll get XY from that turn, and I'll just fill rectangle. X, Y. Amazing. Right, let's see if this thing works. So I will need 2 clients here. Let's refresh both of them. And amazing, we can now make turns, right? You see? I already started to make a slightly useful application for COVID, right? I just made an interactive board, right? So you can exchange a short message. All right, so all right, so but we're in a good shape for our game. So let me remove this other fill rect. I just don't like this black color. And now the next task that we have is we need somehow to identify the users, right? So we could go and write this complicated logging system and somehow make users logging, etc. We just don't have time for that. Usually you would. So my idea is to identify the users through the colors of their token. So what I will do, I'll go on the server and I'll import another little module that I installed before, random color. Require it, random color. And I'll use it to assign for every user. See, this block of code is executed when user joins. So everything in scope of this function is scoped to that specific connection, to that specific user. So I will say that every connection now will have a color. And this is random color. So why I'm using random color instead of writing one line of JavaScript? Well, they say that this module is producing slightly better visual colors, because if you do it fully random, it can be like acidic, that is just unpleasant. This one should be it just should be better, right, in theory. We'll see if it is really better. I'm not sure, but let's give it a try. So now, instead of just sending XY, I will send XY and color. So give me a second. I will just very quickly reformat this function and yeah, make it slightly easier to read. All right, so whenever I'm receiving this one doesn't belong here. Whenever I'm receiving the turn from the client, I'm adding the color to that turn that I have generated when the client connected, and I will send it back with the color. Now, all I have to do is on the client side to make sure that I'm receiving that color from the server, and I'm using that color to give the color to my rectangle, right? So let's see how it works. See, that client is not updated yet. I didn't refresh the page, but once we refresh it, beautiful, we have different colors. So now each player has its own identification, let's put it this way, within our server. And this is a good time to check how is my live deployment looking. So I'll just quickly go game URICOM. Let's see if it works. Yeah, it seems like previous version somehow works, right? So let's see if the next version is going to work. Now, if it works, I'll just open up a window here. If it works, it should refresh at some point and have colors. Then we will be able to play. So if you go connect to that thing and this thing works and it doesn't go down with the amount of users, we'll be able to see the clicks here. All right, so what should be the next thing that we'll do? We have now the canvas. We have the way to exchange the turn information. The next thing is, instead of just pointing on any place in the grid, we will create a grid. Right? We'll create rows and columns and let users click like in a board game. So this is also easy to do. And I'll create a new function here called drawGrid. And now, in order to draw grid, let's think what we need. In order to draw grid, we need to know how many cells do we want in that grid, and I will always go with a square grid. And what will be the size of individual cell? So, oh, yay! There is some connection here, I see. So it's like, oh, yeah, yeah, guys, it's amazing. Thank you for all those clicks. It shows how active we are. It is amazing. Thank you very much. All right, so I'll just close it because it just distracts from the code a lot. But thanks for joining. So let's draw the grid. So we will need to have the size of the number of cells. So I'll pass it here, and I'll do that by default 20. 20 is good. So and then I can figure out what will be the size of one cell. And this one is easy to calculate. Cell size going to be mass dot floor. So I want to round down. I want the integer number of 400, which is the size of the canvas. Obviously, you can take it from the canvas itself, divided by num cells. That will be the optimal size, the maximum size of the cell that I can allow. And now let's talk about how we draw lines, because it's interesting, because in Canvas API, the lines are notoriously difficult, right? If you don't know how they work, you would expect something like draw line. Nah, doesn't work. So everything that is not a rectangle in Canvas is called a path, right? So you are building the path, and then you are stroking the path or filling the path. So that's how it will work, right? So we will start the path, we will move to a certain position on the canvas, then we will do the line to the new position, then we'll move to the next position, and so on, right? You'll see it in code. It's actually easy once you get to it, but if you just start opening the documentation, it's like, what is happening there? So draw grid. I'll start from drawing a single line. TDX, begin path. I tell graphical API that I want to start the path. And this path will start to move to, I will move my virtual pen to some coordinates like 50, 50. And then I will say CTX, line to, come on, that's my typing. And I'll draw the line vertically. So X will be the same, and Y will be like 300. And then I'll say CTX, stroke. So stroke will actually draw the line on the canvas. So, hey, looks amazing. Cool. So now I need to call this function, obviously, to see something on the screen. Draw grid. And I'll take here this function, draw grid. And I can, I'll just call it here. Draw grid. Cool. Let's see if it works. Yay, I've got a line. Amazing. Just, I mean, 4 lines of code for a line. This one is, it's just, but you'll get used to it. I mean, there are higher level graphical APIs as well, but still. All right, so I can draw one line. I can draw many lines, so this is not an issue. And I'll just do for loop. I from 0 to num cells plus 1. So the number of lines is 1 more than the number of cells. And I plus plus. Cool. Then I will take the scope that draws the line. Begin path and stroke I will leave out of the loop. I can first create the paths of multiple lines and then stroke them all with a single call. And this one will be easy. So I'm moving from, so I first will draw the vertical one. So from 0 to num cells multiplied by cell size. This will be how long I need the board to be. Oh, sorry. So I'll start. Sorry, I'll just need to think for a second. So I need to move it to, yeah, sorry, that's wrong. Not to 0. So I want to step in axis to draw the vertical lines. I multiplied by cell size, and it starts with 0. So it will be 0. And line 2, also, I multiplied same X, I multiplied by cell size, but the Y will be num cells by cell size. All right, so let's see if that worked. And that's, there's something wrong with my tab. Give me a second, I'll reopen it. Oh, yeah. Real-time debugging, it's hardcore. Okay, I've luckily spotted the bug. Hope there's not many more bugs. I don't have time for more bugs. So I have the vertical lines going. That was easy. To draw the horizontal lines, you just flip the coordinates, and you'll have the same lines, but not going from the top to bottom. They will be going from left to right. So let's go do that, and I'll just swap the coordinates. You know what? Game development is an amazing way to remember the course of school geometry. So it will all be there. You'll just suddenly realize why you need all those sines and cosines and all the geometrical things. So now we have a grid. Amazing. So that will let me align my clicks on the grid cells. It is not yet done, but I'll do that next. And before I'll go, I want to introduce a couple more functions here. So I will need a function to clear my canvas. And clearing canvas is also super easy. cdx clear rect from 0, 0 to canvas width and canvas height. I'm basically saying I want to clear everything, just to remove everything, make it like it was before. And instead of using draw grid directly, I'll create another, a little bit higher level function. Not higher level function in the functional sense. So I'll create a function called gridset. That will do several things for me. So it will clear the grid first. Not the grid, but whole canvas. Clear the canvas first, and then it will draw grid. Why do I want to have this extra function? Well, because if I will have an additional elements of UI, I would put them all here. So this is the initial state. When I have the game started, I'm calling reset, and that's how I draw everything that I need. So I don't want to expose draw grid anymore. I'll just expose reset, save it, and let me just call it here reset and here reset. All right, so give it a shot. All right, so it still works. I can still click, and it's time to push. So, all right, pushing. And the next step is obviously to align the clicks to the grids. How it looks here. Wow, somebody is like with purple is doing real art here. All right, so let's align our clicks to the grid so that the players can actually click in the cells. So this seems like an easy task, but just pay attention on this.
2 minutes.
Oh shit! Really? Oh, sorry. Can I have 5? Okay. We'll just do that really quickly. So we'll align it to the grid, and here you're transforming from the screen coordinates to the actual canvas coordinates, right? So, and this is it's super easy to do as well, because it's a simple view. In isometric view and 3D view, maybe a little bit more work, but no. So get cell coordinates will be the function that accepts screen coordinates, so coordinates of the canvas, and it will return the coordinates of a cell that this click, or this position rather, belongs to. And that will be x. X will be mass, or from x divided by cell size, and the same for y. And you can check the formulas. It's quite easy in reality. You just figure out which cell this guy belongs to. And don't forget to expose its function, get cell coordinates, and start using it. Get cell coordinates. Okay, so now, instead of sending the turn through the cell coordinates, instead of sending to the server the screen coordinates like we were doing before, say that we're using get cell coordinates and pass xy there. So now our server knows exactly which cell you clicked. And in order to render that cell, instead of fill rect, let's remake this function to fill cell. And the refactoring will be super easy. You just need to multiply by cell size to put this exactly to the right place, right? So if I did everything correctly, and this doesn't bug out, fill cell, and fill cell here, fill cell, I will be able to send the clicks on the exact cells, right? So fill cell, I need to use it now somewhere here. fill. Right, let's see if that works. I think I'll do maybe 1 more minute of code. And you see now it's perfectly aligned, right? So if I have 2 players, we can exchange turns now. Cool. So probably I will not be able to finish it all, guys. I'm really sorry. But what I really want to show you one more bit, right? So now the thing is, how do you build the game logic there, right? You need to store it somehow. So we'll start from saving the state of the string and giving it back to the user. So when you're logging into the game, the level is already changed somehow. The players are interacting with that level. So we'll do the same idea here. We'll be saving on the server the state of this board and then giving it back to the user when the user logs in, right? And again, I cheated a little bit. I have created a very little helper function that is called create board, and I did it just not to write lots of array manipulation code, because you need to initialize 2-dimensional array, and then all you really do is you just save the value in that array. So I'll do that really quickly. So now what I want to do is I want to have my set of functions for my array manipulation, and it's called create board. Create board is going to come from create board. And we're not creating a board for a single user, we're rather creating it for the whole server, so everyone is on the same board. And that create board exposes the method called make turn. Create board of size 20. This make turn will, in reality, it's just setting the value in the array, so there is no magic there. And we'll say that whenever we have a turn, say make turn XY color. And we're saving the board, and it's time to give it back. And whenever the user is connected, I'll just take the current state of my array. It's a get board function that I built for that. And I'll do board. I'll send a new type of message, and I'll send get board. I promise I will wrap it up soon. Just give me a couple more seconds, please. So I'm emitting the board. I'm sending the board to the client, and now all client needs to do is client needs to start reacting on that, right? So we'll say, all right, so what happens if somebody sends me the board? Well, I need to render it. And in order to render it, I'll just reuse the same method that is called reset. I will be piggybacking on the same function, and I'll just add right now a very simple bit of code to the reset method that draws the board. For board, make it a separate function instead, probably will be a little bit cleaner. It accepts the board, and we'll say for each row in the board, I'll take row and y coordinate, and then for each cell in that row, that will be in that cell, I will find the color, and the coordinate will be x. Yeah, I'm coming. I'm finishing. Color and fill cell. Just last bit of code. You know how it is.
Oh yeah.
Hate to leave it unfinished. Color. Right. So now the final bit, final touch. Reset. We'll say that reset accepts the board, and we'll draw this board. Right. If that works, we'll have the game state in place. Right. Let's check it out. Right. See, now I'm refreshing the page, and I'm coming to the same state as was before. And the final thing that I'll do is I'll just push it so that you guys can play with it. There was one bit more, right? So to add the win conditions, but you can figure out how to do that, right? You have everything now. In the server, you have the board that contains all the figures, so you can build any sort of game logic. So who has hit more cells, who has hit 5 cells in a row, etc., and so on. So I'm really sorry to take a bit more time than I was expected. No, can you push my my camera, please, back to the screen? Just a couple of final words. So Thank you very much for attending this session. It was really nice to work with you guys. And the source code, as I said, will be available on my GitHub repository. You can find GameYuri.com and Yuri.com. There are links to the code, and maybe we will continue that in some other format in a workshop session or something. So thank you very much for joining. It was a pleasure to talk today in front of you all. So enjoy the rest of the conference. Bye, guys.
Thank you, Yuri. That was an amazing presentation, and the chat was booming from the messages. Hey, I know this guy. So you got a lot of followers from YouTube. So you're doing a great job. Thanks a lot. It was super interesting. You can ask the questions to Yuri on our Q&A panel.